Hey everyone, and welcome. So, I know everybody is talking about large language models, but today we're going to dive into the tech that's often overlooked, the stuff that makes AI actually smart and useful. It's the critical piece of the puzzle. So, let's just jump right in. Have you ever been in this situation? You've got this incredible AI, but you're just frustrated that it can't access your company's own specific knowledge. Like, it can't answer a simple question about your own internal docs. That's because there's a missing piece, a kind of bridge between the AI's general smarts and your own private data. This quote just hits the nail on the head. It perfectly captures the core problem, right? LLMs are trained on, well, the entire public internet, but they know absolutely nothing about your private world. This creates what we call a knowledge gap. And honestly, it's the biggest roadblock to building AI apps you can actually rely on. And just think about where your company's most valuable information lives. I bet it's not in some perfectly organized, neat little database. No, it's trapped in this messy pile of what we call unstructured data. PDFs, support tickets, endless meeting notes. The thing is, an AI can't use what it can't understand. So all of this leads us to the root cause of the problem. And it turns out the way we've been searching for information for decades, literally just using keywords, is fundamentally broken for modern AI. It just doesn't work anymore. The most important thing to get here is this. Keyword search is totally literal. It just looks for the exact words you typed. It completely misses what the user actually means. And this massive disconnect between the words people use and what they intend, well, that's a huge problem. Okay, let's look at a perfect example to make this real. Imagine a customer asks your AI chatbot about your refund policy. Simple enough, right? But your internal document, the source of truth, only ever uses the word cancellation. So what happens? Keyword search sees 0 matches. It completely fails, leaving your customer frustrated and, frankly, your AI looking pretty dumb. So how in the world do we fix this? Well, the solution requires a complete shift in how we think about search. We have to move away from the words themselves and start focusing on their underlying meaning. It's a whole new way of looking at things. And the key concept that unlocks all of this is something called semantic similarity. It sounds a bit technical, but the idea is pretty simple. It's just the ability for a machine to understand that refund policy and cancellation are conceptually related, even though the words themselves are totally different. It's all about context and intent. So yeah, the big goal here is to finally graduate from just matching keywords to truly understanding meaning. This conceptual shift is the absolute key that finally unlocks all of that valuable, messy, unstructured data for your AI to use. Okay, so that's the what. But how does this all work under the hood? Let's break down the vector database workflow so you can see the practical solution in action. It really just boils down to this pretty simple 3-step process. First, we create something called embeddings. Then, we store them. And finally, we search them based on similarity. Let's just walk through each one really quick. All right, first up, embeddings. This is where your documents, your meeting notes, even your images get converted by a model into a long list of numbers. We call this a vector. And this vector is basically a mathematical fingerprint of the content's meaning. It's kind of like a universal language for concepts. So now that you have all these vectors, you need a place to put them. And you can't just throw them into a regular old database that's built for text. Nope. They need to be stored in a specialized vector database, which is purpose-built to index and organize all this information, not by words, but by their conceptual meaning. And finally, this is where the magic happens. When a user asks a question, their question also gets turned into a vector. The database then does a similarity search, instantly finding the vectors and the original documents that are mathematically closest in meaning, not in the words they used, but in what they meant. So that's the tech. But what does this actually let you do? Why should you care about this for your product? This is where we see the real-world impact, powering much smarter and way more accurate AI. This entire workflow we just walked through, it powers a technique called RAG. It stands for Retrieval Augmented Generation. Honestly, the best way to think about it is that you're giving your AI a perfect long-term memory of all your private data. So instead of just making things up, the LLM is first given the exact relevant context it needs to give a real accurate answer. The benefits here are just huge. You get answers that are grounded in your actual documents, in facts, not fiction. You get a search function that actually understands what your users want. And you can build these incredibly smart recommendation engines that suggest things based on true conceptual similarity.
So look, the most important thing to take away from all this is this. If you're building a serious AI application, you have to build for accuracy and scale right from day one. And moving beyond keyword search to a robust vector search system is, well, it's absolutely non-negotiable. And that really leaves us with one final question to think about when it comes to your own systems. Is your AI just creatively guessing? Or, with the power of your own data behind it, does it truly know?